Hello everyone. Today we are going to see chapter 8 of science, that is force and pressure. In this chapter we will see what is force and what is pressure. So let's start. What is force? Force is a push or pull of an object. When we apply a force on an object, the object comes in motion. So motion is change in position of an object with respect to its surroundings in a given interval of time. States of motion. There are two states of motion, state of rest and state of motion. When the position of an object does not change with respect to its immediate surrounding, we say that the object is in a state of rest. Here the object is the tree. If we apply a force on this tree to change its position, it will not change. So we say that the object is in state of rest. When the position of an object changes with respect to its immediate surroundings, we say that the object is in state of motion. So here the object is the train. If the engine is switched on, the train moves from one place to another. It is changing its position, so we say that the train is in motion. The object is in motion. Actions of force. On application of force, different kinds of actions can be observed, like picking a fruit, opening a door, kicking a ball, pushing a heavy weight, shutting a ball, hitting a ball, lifting a heavy weight, flicking the marbles, and pulling the rope. So in all these actions, what we can observe is that when we apply a force on the object comes in motion. In other words, we can say that the motion imparted to objects is due to the action of force. Forces are due to an interaction. An interaction of one object with another object results in a force between the two objects. The objects, they can be in contact with each other or they may not be in contact with each other, but still the forces are present between them. Exploring forces. If the forces are applied in the same direction, they are added up. Here, two persons are lifting the sofa and they are moving in the same direction. So, whatever the force they are applying, that will be added up. This man is applying a force of 30 Newton and this man is applying a force of 45 Newton. Here, N is Newton, which is the SI unit of force. Since they are moving in the same direction, their forces will be added up. That is 45 Newton plus 30 Newton equals 75 Newton to the right. Forces applied in the opposite direction of an object. The net force acting on it is the difference between the two forces. Here, this team is applying a force of 450 Newton and the other team is applying a force of 500 Newton. So, to calculate the total force, the two forces had to be subtracted. 500 Newton minus 450 Newton, that is 50 Newton, which is the total force acting on the object. The strength of force is usually expressed by its magnitude. If the direction or the magnitude of applied force changes, its effect also changes. More than one force may be acting on an object. A force can change the state of motion. An object can be at rest or in motion. The state of motion of an object is described by its speed and direction of motion. The state of rest is considered to be a state of zero speed. When a force is applied on an object, the object comes in motion and the force applied on an object may change its speed. If the force applied on object is in the same direction of motion, the speed of an object increases. If the force is applied in a direction opposite to the direction of motion, the speed of an object decreases. A force can bring a change in the state of motion of an object. Characteristics of force. It may make an object move from rest. It may change the speed of an object if it is moving. It may change the direction of motion of an object. It may bring about a change in the shape of an object. It may cause some or all of these effects. Now, types of forces. There are two types of forces. Contact force. In this, the objects are in contact with each other, and non-contact force, the objects are not in contact with each other. Contact forces are muscular force and friction force. Non-contact forces are magnetic force, electrostatic force, and the gravitational force. Contact forces, muscular force. The forces caused by the action of muscles in our body they are known as muscular force. Like example is that drawing water from the well, movement or bending of our body, process of digestion of food, process of breathing, carts drawn by animals. Friction force, force that opposes the motion when the surface of a body comes in contact with that of another body. The force of friction always acts on all the moving objects and its direction is always opposite to the direction of motion. Here, the boy is pushing this wooden block in a forward direction, but the force of friction is acting in the backward direction. It is opposite. A ball rolling along a ground slows down and finally it comes to rest. Pushing a table or a block on a rough surface. A car or a scooter comes to rest when the engine is switched off. A boat comes to rest if we stop rowing it. Non-contact forces. Magnetic force. Force between the magnets can be attraction or repulsion. Attraction or repulsion between the objects is also seen as another form of push or pull. Here, unlike poles, they attract each other, and the like poles, they repel each other. A magnet can exert a force on another magnet without being in contact with it. Electrostatic force, the force exerted by a charged body on another charged or uncharged body is known as electrostatic force. A comb becomes charged when rubbed on hair and it attracts the uncharged pieces of paper. Similarly, a balloon gets charged when rubbed with a cloth and it also attracts the uncharged pieces of paper, or else it can also stick to the walls. Gravitational force. Every object in the universe, whether it is small or large, exerts a force on every other object. This force is known as the gravitational force. Objects are things that fall towards the earth because it pulls them, and this force is called force of gravity or just gravity. It is an attractive force. A ball falling down when thrown from a height, leaves and fruits they fall to the ground when detached from the plant, and a person falling down from a height. Pressure. The force acting on a unit area of a surface is called pressure. They are considered to be the perpendicular forces. So pressure is equals to force upon area on which it acts. Pressure and area, they are inversely proportional. It means if the area is more, the pressure applied will be less, and if the area is small, the pressure applied will be more. So if we look at this figure, in this picture, the two bags are there. One is having a broad strap, means the area is more, so the pressure applied on our shoulder is less, and in the another the strap is thin, so area is small and the pressure applied on our shoulder will be more. Smaller the area, larger the pressure on a surface for the same force. Hammering a nail, here the bottom of the nail, it is very sharp and the area is small, so a greater pressure has to be applied on the top of this nail. Sharp knife is there, so the area of sharpness is large, and if the area is large, the pressure we have to apply is small, So we can easily cut the fruits or vegetables with a sharp knife. But if the knife is blunt, the sharpness area is small. So we have to apply a greater pressure to cut the fruits or vegetables. Pressure exerted by liquids and gases. Liquid exerts pressure on the walls of the container. We will understand this through some activities. So, in figure A, there is a plastic tube which is open at both the ends. So, it is filled with water and a rubber balloon is being attached at the bottom. As the water level is maintained, the balloon bulges out. If we increase the amount of water, so the balloon bulges out more. In figure B, a plastic beaker is there or a plastic container is there in which three different holes are made at certain heights. So the water at the depth, it comes out with the greater force because here the molecules of water which are there, they experience a greater pressure, and because of that they come out with a greater force. So from figure A and B, we can say that the pressure exerted by water at the bottom of the container, it depends on the height of the column, the height of the water level. In figure C, a bottle is there in which a side hole is made and a balloon is being attached to it. So we see that the balloon bulges out, and this shows that a liquid exerts pressure on the walls of the container. In figure D, again a bottle is there and in that the holes are made at a same depth. We see that the water from each hole, it comes out with the same pressure. So this shows that the liquid exerts equal pressure at the same depth. So in all these activities, we had seen that the liquids exerts the pressure on the walls of the container. If we look at this concept, liquids are made up of very small number of particles and they are having a rapid motion and they are continuously colliding with each other and also with the walls of the container. When these particles collide with the wall, they exert a force on the wall and thus exert a pressure on it. Example like leakage of water from water pipelines or the taps. Gases exert pressure on the walls of the container. A gas exerts pressure on the walls of the container because the particles of the gas, they move randomly in all the directions at a high speed and there is very little force of attraction between these molecules. So they move randomly. As a result, the particles, they frequently collide with each other and also with the walls of the container. Example is whistling of pressure cooker when a balloon is being inflated. Atmospheric pressure. The envelope of air is known as the atmosphere. The air around us has weight and it presses against everything it touches. The pressure exerted by this air is known as the atmospheric pressure. It is this force, the force exerted on a surface by the air above it as gravity pulls it to the earth. It extends up to many kilometers above the surface of the earth. The pressure inside our body is equal to the atmospheric pressure. Atmospheric pressure is measured by an instrument called barometer. How large or small is the atmospheric pressure? So this we will understand this with the help of a rubber sucker. This is a rubber sucker. When we press the sucker on a smooth surface, usually a glass or tiled surface, most of the air between its cup and the surface, it escapes out. This causes the space between the surface and the sucker to have a low pressure. The contact between the rubber sucker and the smooth surface is airtight. Here, the rubber sucker and the wall, they are tightly connected. An airtight connection is there, and inside the rubber sucker the air pressure is very low. The external atmospheric pressure, which is much higher, acts on the rubber sucker, pressing it securely against a wall. So, to pull a sucker off the surface, the applied force should be large enough to overcome the atmospheric pressure. If this video was helpful to you, then please like it, share it, and subscribe it. Thank you.